Okay, welcome guys to the finale of this whole paper, actually the senior section only. So now we will be discussing problems 19 and 20, and problem 20 will be a mouthful. So let's look at problem 19 first before we reach our peak, our apogee, our zenith, our culmination, something like that, okay? So problem 19, determine the number of pairs of non-zero integers m and that satisfy the following equation. M and n are different, so 1, 2, and 2 want to consider different pairs, and then we will have this equation over here. So what we will normally do first is we will multiply out and then we will expand the equation. So on the left hand side we will have m cubed plus m squared n squared plus n plus n cubed will be equal to m cubed plus 3mn squared plus 3m squared. And okay, I just mixed it upside down, but don't worry. So we know that we see here that both sides have m squared, m cubed, and n cubed, so we can remove these. So we have now m squared n squared plus mn is equals to 3mn squared plus 3m squared n, and then we can actually factorize out the mn over here. So mn times bracket mn plus 1 is equal to mn times 3m plus 3n. Okay, so because m and n are both non-zero integers, so actually we can remove this, because if this one actually means that mn is 0, so we can remove this. So we have mn plus 1 is equal to 3m plus 3n, and then this one we move both 3m and 3n to the left hand side. We'll have mn minus 3m minus 3n plus 1 equals to 0. Now what I want to do over here is the how to say, in Chinese we will say 无中生有, but in English I don't know how to translate it. Maybe it's something like making something out of nothing. So now, because I want to factorize this, actually I want to make it in such a way that this is factorizable. So what I would do over here is mn minus 3m minus 3n plus 1 plus 8 is equal to 8. So some of you are confused. Why would I use 8 over here? So this one is actually 9, right? So I can factorize this whole thing into m minus 3 times n minus 3 over here would give us 8. So this 8 will be can be possibly broken down into maybe say 1 times 8, and then maybe say 2 times 4, and then 4 times 2, and then 2 times 1. Okay, so what do we have over here? So the number of pairs of the number of pairs of m and n that satisfy the question 19. Okay, if we say m minus 4 and then m and then n minus 4, and no, sorry, I just wrote the wrong number. So we'll draw kind of like a table kind of stuff over here. M minus 3, m, n minus 3, and n. So m minus 3 in the first case there's 1, and then we have 8, and then so here we have 4 and then 11. So and then the second case will be 2, 4, and then this one will have a give 5 and 7, and then 4, 2, 7, 5, and then 8. So this one, sorry, I said 8 and 1. So this one will give us 11 and 4. So if you guys are not sure about the possible values over here, so maybe 4, 11, 5, 7, and then 7, 5, and then we have 11, 4. So if you guys are not sure, let's take one number and then substitute it inside, and then we check if this is true. So maybe say, because actually I think we need to do 2, because we have 2 different combinations over here. Just do 4, 11, 5, 7. So 4, 11, so maybe say m equals 4 and n equals to 11. So 4 squared plus 11 times 11 squared plus 4 is equals to 4 plus 11 squared. Is it true? So we have 16 plus 11 is 27 times 125 is equals to 3375, and then this one is 15 cubed. 15 cubed is also 3375. So this is true. Okay, so 4, 11, 11, 4 are definitely true. So we have already 2 pairs over here. And now And now what we want to look at is the pair 5, 7. The pair 5, 7. 5, 7. So 5 squared plus 7 times 7 squared plus 5 is 5 plus 7 cubed. So this one is 32, 54. This is 1728, and then 12 cubed is also 1728. So this is acceptable. But oh, I have missed out something. So it is always very important to read the questions like twice or thrice in order lest you lose valuable marks because of one simple mistake. So what the problem 19 here states that non-zero integers actually also consist of negative integers. What do I mean? So besides these are all positive, these are not wrong, but these are just part of the whole equation. So we can also have -1 times -8. We also could have -2 times -4. Or -4 times -2, and then -8 times -1. Okay? Yeah, so I'm writing like in this way. And so we need to extend our whole graph over here. So maybe -1 and then -8 and then -2, -4. So the other two are just the same, just swapping numbers only. So if m-3 equals to -1, m would be 2. And then if n-3 is -8, then n will be -5. And then if m-3 is -2, n will be 1. n-3 is -4, n will be -1. So let's check the pairs 2 and -5, and then it's, how do I say, it's upside down one, so there also be a -5 and 2. And then for this pair 1 and -1, we also have the pair -1 and 1, but we'll just check these two again. So I'm sorry if this takes up a lot of time. We're just doing the whole procedure in a most efficient way possible already. Okay, so we have, what pairs do we have? 2, -5, 1, -1. Okay, 2, -5, then 1, -1. So this one is a pair. Okay, so substituting 2 times 2 squared plus -5 times -5 squared plus 2 would give us 2 minus 5 cubed. So this one is actually -1, and then this one is 27. So -1 times 27. This one is -3 cubed is also -27. So this is feasible. And the last pair over here, so this one I'll erase it. Okay. So the last pair is 1 and -1. So yeah, lesson learned. Look at the problem twice or thrice. So how do I say? Okay, 1 squared plus -1, and then we also have -1 squared plus 1 would have 1 minus 1 squared, because this is 0, and then this is 2. 0 times 2 is 0. 1 minus 1 is 0. So 0 cubed is also 0. So this is also feasible. So we do not have only just the last 4 examples, the positive ones. We also have the negative ones. So actually this is kind of a fun question over here. So now we have these 8 pairs. So in total, our answer to problem 19 would be 8. So jot it down. And for problem 20, wow, this is a very long one. So I'll erase my stuff for a while and then we'll get back soon. Okay? Okay, now we move on to problem 20. This one is the longest one in the whole problem set actually. So let me try to read it out. Maybe try an English accent, okay? There are 31 students in the class. Call them student 1, student 2, student 3, and so on. A teacher writes a number on the whiteboard, and then each of the students makes a statement about the number. Student 1 says that the number is divisible by 1, and then student 2 says that the number is divisible by 2. Then student 3 says that the number is divisible by 3, all the way down to student 31, who says that the number is divisible by 31. Finally, the teacher says that each of you made a true statement except for 2 students. Moreover, these 2 students made their statements consecutively. Which student made the first false statement? Okay, maybe I'm mixing Manglish and British blah. Okay, so that's not important. The important one is the important points over here. 2 students made the wrong statements, and then they made their students consecutively. So which is maybe the first one is n, and then the next one will be n plus 1. So this one, observing this one must definitely be either one odd, one even, no? But we don't know which one comes first. So and then we need to consider some cases. Okay, I think I need to gather my thoughts over here for a while, so maybe you might hear some moments of silence because I was contemplating, I was pondering. Okay, so now who made the so what kinds of numbers for n and n plus 1 are there such that we can confirm that, oh, this very big number which is divisible by almost every number from 1 to 31, I can say that this number is not divisible by n. So one case would be prime numbers. So this is our first case. But specifically prime numbers which are larger than 31 divided by 2. And now why do I say so? Because take an example. Maybe say 13. 13 is a prime number, and it is smaller than half of 31. But if you say this number is not divisible by 13, consequentially, all of these cases are actually have consequences. If say this number is not divisible by 13, and then this number would not be divisible by 16. No, 26. So these two are not consecutive. So we can't use prime numbers which are smaller than half of 31. So we need to maybe jot them out. Maybe we can have maybe you can have 17 and then 19 and then 23, 29 and then 31. So consecutively, right? And then a second case, I'll just be stating my facts. I won't be elaborating much about how I came to these things lah. I'll be elaborating them once I say my statement lah. So the second case in which this very big number is not divisible by one of the numbers between 1 to 31 is that this number is a perfect power. So this number is a perfect power, meaning that it's in the form a to the power of b, in which b is larger than 1. So some numbers over here, some examples will be 3 squared, which is 9, and then 25 squared, and then maybe say 16, which is 2 to the power of 4. So this 25 is 5 to the power of 2, and I just wrote wrongly, sorry. Okay, so why can we say that, oh, these numbers maybe cannot fully divide this whole number? One possible statement might be because maybe take 25 equals to 5 squared as an example. Maybe say this number is divisible by 5. If I were to say that this number is not divisible by 5, then consequentially, then this number will also not be divisible by 10, 15, 20, and so on. But if I say this number is not divisible by 25, but is divisible by 5, there are numbers like this. It's the same logic as all multiples of 9. All multiples of 9 can be divisible by 3, but not all the multiples of 3 are divisible by 9. Is this kind of logic, this kind of analogy. So I'll be erasing this one because I need to make some space for my problems. Yeah, so basically we have boiled down to mainly these two. And then I should say here that composite numbers here are a big no-no, are a taboo over here, maybe something like that. Because take an example, maybe say 30 and then 31. Okay, so maybe say this big number is not divisible by 30 and 31. So if it is not divisible by 30, so something must be wrong inside here. If we can break down 30 into 2 times 3 times 5. So if this number is not divisible by 30, then either it must not be divisible by either 2, 3, or 5. One of it is not cannot divide the number mentioned above. And then this one will have a great impact because why? Maybe say, for example, oh, this number is not divisible by 3, and then consequentially, again, I'm using the word consequentially, it cannot be divided by 6, 9, 12, all these multiples of 3. No. So composite numbers are here a no-no, but perfect powers, even though they are composite numbers, they can be accepted because of the analogy I have mentioned just now. So now we just need to list out all the numbers, all the possibilities that I mentioned just now. And then actually, to be honest, any number under half of 30, any number half of any number half under half of 31 cannot be false, okay, because you will have times 2, and then maybe say, for example, 14 is under 31 divided by 2, you have 28. If this number is not divisible by 14, then this number is also not divisible by 28. So we can only pick numbers, specifically prime numbers and perfect powers larger than half of 31, okay? So now we have the whole list. Now we have 2 to the power of 4 is 16, and then we also have 3 to the power of 3 is 27, and then we also have 5 squared equals to 25. And then do we have any more? Okay, so now we list out all the possibilities. We have 16, we have 17, 19, 23, 25, 27, 29, and 31. So over here, the only 2 numbers which are consecutive are 16 and 17. And the first student which made the first false statement is actually student 17. So I'll write my answer over here because I've written a bunch of maths over here. So yeah, this is how I solve my problem. The main concern over here is to observe the fact that any number under half of 31 cannot be used because multiplied by 2, then consequential influence, I can only say so. And yeah, I hope this one I have explained it clearly enough. And so this is the end of our whole discussion thing of this senior category of the sample 2 of IMONST. I wish you guys a very successful, very astonishing results in the IMONST. I wish you all can also be selected into the second round, because I also have my own aspirations. I also want to be selected into the second round. Okay, I'm quite desperate right now. I'm feeling old already. Okay, so that's all for today, and cheerio. See you guys next time. Bye bye.